Okay guys, welcome back to my video, to my channel. Don't forget to subscribe my channel, Fish Pro Learning. So today we like to continue this. I have told you before about our practice in the Laplace transform. So I have five questions, so we can do it together. So for the first, don't forget I already for the Laplace table. So we have a Laplace table, so I will give you, or you can refer to the Google Classroom that I have uploaded for this one, for the Laplace table. So I will write back, because I didn't have any printer, so I need to write back for the one by one. So for the first one, first of all, this is why I stand by here. So we start for the first question, which is how to find the we want to transform the function ft. So the number one, if the ft is equal to t. So it is very simple, but don't forget, if we use Laplace transform here, so the ft, so we want to Laplace the function of ft here, so this means we want to Laplace the function of t. So if you remember, what is the basic for the Laplace here? So the fs equal to the limit from 0 to infinity t times with the e negative st dt. So it's look like complicated, right? Because we require to use the integration by part. Do you still remember about the integration by part? There's two condition here, the integration by part. So I put back. So this is the integration by part. So if you remember here, you can, this one also, this integration by part. So here you require to use u dv equal to uv minus v du. So you need to identify which one is u and which one the dv. So here the u is equal to t, and dv is equal to e negative st. So you can write here u v du and dv. So you now already have u is equal to t, and then dv you have e negative st. So how want to find the dv? You need to find the v. So dv to v, you need to integrate this one. So it is equal to e negative st s. So for the t, you need to differentiate of t, means uv, this one is a dt, or 1 t, if you difference equal to 1 times 2 dt. So you already get here. So what's next? So you put back into this integration by part, all here, integration by part. So you write back, so this one, integration u dv equal to uv, uv t times with the e st over s minus with v. Integrate the value of v here, e negative st over s. You get it? So here can write negative t e negative st over s. So this one you can go to plus. Yeah, this one, this integer, you can pull it out. So 1 over s integrate with the e negative st dt. Okay, okay, you get it? Okay, so what next? E negative st over s plus, okay, this one you integrate 1 over s integrate with the e negative st over s plus c. So this is the constant. So this is the theory for the integration theorem. Okay, so final here, negative t e negative st over s plus e negative st plus s2 plus c. Okay, don't forget here the limit is from 0 to infinity. Okay, for the function of t, right? So here you can write negative t e negative st plus s e negative st s2. The limit is 0 to infinity. So I think all of you is familiar about this one, how to put inside. So put inside, so you change the value t with the infinity. So this one infinity e st s infinity plus s plus e negative s infinity to minus with, okay, minus with the, okay, 0 put in t, so it is equal to 0, and then plus 0 change to the t, place with the 0 means equal st times 0 equal to 0, exponent times to the 0 is equal to 1, so 1 over s2. Okay, so if the infinity times to the exponent s infinity, so this one infinity, so equal to 0, so this one infinity equal to 0, so this one can be 0. And how about this one? So e minus s infinity also is equal to 0, so this 0 0. Okay, oh, forgot this one, t negative est, this one the plus, oh sorry, this one is a negative, so this one the negative, so this one the negative, so this one is a negative, so this one is a negative, so negative and negative means positive, so 1 minus s2. So this is one the final answer. Okay, you get it? Okay, so don't make it mistake like me. Okay, so this one the negative times the positive is negative, so this one we change to negative. Okay, negative, and this one is negative negative and negative is positive, so the final answer is 1 over s2 for to transform from the time domain to the frequency domain of function t is equal to t. So this one the function here. Okay, but it's okay. I just want you to practice about the integration by part, how to use it and how to implement it. Actually, in the Laplace transform table, we already have the function of t and ut. So if you want to transform, is factorial of n over s n plus 1. So means here, if t t and ut, if you want to transform here, the number of n here, this is what the n, so the factorial 1 factorial plus s plus this one, the number of n is 1 plus with 1, so equal to 1 over s2. So this is a simple way if you use the Laplace table. Okay, so but it's okay, I just want you to practice using the integration by part. If you have any question, if you get any question from others to use the integration by part, so all of you are already familiar with this one. Okay, so I think we can go for the next question here. Okay, we go for the next question. Okay, the question number 2, when the ft equal to t power of 4. Okay, so we Laplace, so we Laplace back the curly Laplace here, the value of ft equal to Laplace of t4. Okay, so for this one, this is number of n, so you can refer to the table. Okay, t power of n means the factorial of 4 here. Okay, s number of n plus 1, so factorial 4 times 3 times 2 times 1, and s was a 5 power of 5, so this one is a 24 over s 5. So this is the final answer. Okay, so for the third question, we have ft equal to sine 2t. So here we want to transform the Laplace ft equal to Laplace s sine 2t. Okay, back to this table. Okay, you can find where the sine, so here's sine here. Okay, sine omega t ut, so means this one you can write here, you can use the omega 1 s2 plus omega 1 2 is equal to 2 s power 2 plus 2 power 2, so equal 2 s power 2 and 2 power of 2 is 4. So okay, simple, right? Okay, so we go for the next question. Okay, for the number 3, okay, Laplace here. So the question is 5 e 2t minus t power of 3. Okay, so based on this one, we just use the Laplace table. So how about this one? Okay, if I write to the Laplace means here, okay, from negative infinity, from 0 to negative infinity times with the e negative st 5 e2 exponent power 2t minus t3 dt. So I think you can separate for this one. Okay, but you can separate this one like this one. negative infinity e negative st times with a 5 exponent 2t dt plus 0 infinity e negative st times with the negative t power of t dt. Okay, according this one, I think you can refer to this table. Okay, so this is the function of Laplace. So how, right? So this is the function Laplace. So this is e 2t plus with the Laplace e negative 3 power of t. Okay, so you can refer to the exponential. So here, so how this one will be, so the 5 you can pull out here, pull out times with the 1 over s minus 2. Okay, and then minus with, okay, plus the Laplace here t factorial. Okay, this one the negative and positive. Okay, you can write a negative here. So t factorial means how you want to write? So this one the 3 factorial s3 plus 1. Okay, so this one the final answer is 5 s plus 2 minus 3 factorial means here 3 plus t times 2 times 1, okay, equal to 6 over s power of 4. Okay, so simple, right? Okay, for the last question, okay, we go for the last. Okay, for the last, the function of t. So this is the exercise number 5. How if the function like this one, t equal to minus 7 plus cos 2t. Okay, so here, so you already done to know this one, and how about this one? Okay, so this is 7 ut, right? So ut here is equal to 1 over s. So if you ft equal to, okay, I straightforward here, straightforward to do negative 2 s2 plus 1 minus, okay, 7 you can pull out, the ut is 1 over s plus, okay, cos, okay, for the cos here means, okay, s plus s over s power of 2 plus 2 power of 2. So 2 factorial is equal to s power of 3 minus 7s, okay, plus s power of 2 plus 4. Okay, I hope all of you can make it familiar about the Laplace based on the Laplace table. So in the test and the assignment also, you can refer the Laplace table here, so don't worry. Okay, this table is provided, don't worry. So easy, right? Have any question? Do you have any question? Okay, so make sure you must know about the integration by part, even they have it's a provide by the table, okay, like this one, but you must know the integration by part too. Okay, this don't make a mistake like this one. Okay, okay, right. Okay, if any question you can ask me, and let's be further for the next topic. Okay, we will cover to the zero and pole, convergent, and so on before we continue for the bilateral. For this one is unilateral. Okay, thank you very much, and don't forget to subscribe, like, and comment about this video. Okay, thank you very much. Okay, bye bye.